Okay, today we'll start the second part of testing hypothesis. Testing of hypothesis. Actually, we are test the students T distribution, F distribution, and chi-square distribution. This is the second part. In previous class, we have studied about more about F distribution and types of distribution, classification, and properties, characteristics of test of hypothesis. We have discussed in our previous lecture. This is the actually part 2. Today we'll start with students T distribution. So actually how to do T test. Students, first of all, what is students T distribution and when we use students T distribution? This T distribution is used when the sample size is less than or equal to 30. If the sample size less or equal to 30, then we can use the students T distribution. This is the actually important. This is the important part of T distribution. For a small size, we use students T distribution, and the population standard deviation is unknown. Okay, so T statistic is defined as T equals to x bar minus mu divided by s divided by root over n, and variate to T of n minus 1th degree of freedom. Actually, here df equals to degrees of freedom, and s is the standard deviation. Okay, for the population standard deviation, and this is the population n minus 1 used for population, whole population. So a standard deviation s equals to, this is the standard deviation formula, summation x minus x bar whole square divided by n minus 1. Actually, T table for students T distribution, there is a table for the probability integral of T distribution. The T distribution has different values for each degrees of freedom, and when the degrees of freedom are infinitely large, the students T distribution is equivalent to the normal distribution. This is the another part of properties of T distribution. Which one? The students T distribution is equivalent to the normal distribution when the degrees of freedom are infinitely large. The probabilities shown in the normal distribution tables are applicable. Now, application, there are various types of application for students T distribution. Some of the application of T distributions are given. First of all, you have to use this, that means to test if the sample mean x bar differs significantly from the hypothetical value mu of the population mean. The mu is the actually population mean, and x bar is the sample mean. Remember it. There are two types of mean. One is x bar. X bar is the sample mean, and mu is the population mean. Another one, to test the significance between two sample means. Suppose there are two sample mu x1 and x2, then to test the significance, we have to use this T distribution. Another one is to test the significance of observed partial and multiple correlation coefficients. In correlation coefficients, we have studied about this multiple correlation, partial correlation is also part of correlation coefficients. Now, the critical values of T. The critical value or significant value of T at a level of significance alpha degrees of freedom, gamma for two-tail test. Actually, you must know about tail test in our first lecture. In details, we have studied this. Probability of T distributions is must be greater equal to T gamma alpha, that will be equals to alpha. This is the alpha is the critical value, and another critical value will be for less equal to 1 minus alpha. Two tail, the left tail, left right tail, and this is the left tail. So the significant value of T level significance alpha for a single tail test can be determined from those of two tail test by the referring to the values of twice alpha. Actually, the range is what? Twice alpha, the length. Now t-test significance for the mean of a random sample. If H naught is the null hypothesis, the sample mean is x bar and the population mean is mu, then we use the statistic T for a student's T distribution. T equals to x bar minus mu divided by s by root over n, where x bar is the sample mean and mu is the population mean. So and S is the standard deviation for the population, and with the degrees of freedom what, n minus 1. N is the what, number of, total number of frequency. Okay, degrees of freedom. So at a level of significance alpha 1, the degrees of freedom will be n minus 1. We refer T table T alpha two tail test or one tail. If we calculate T values for the critical values, this is for the left tail and this is the for right tail, and H net is rejected for this. Now this is also T distribution for the critical values T alpha for the acceptance of H net and n minus 1 degrees of freedom. If less equals to acceptance null hypothesis. In 95% confidence level, the significance 5% will be x bar plus minus t 0. It is the actually critical value 0.5% significant, and this is the 1% significant. In 99% means what? 1%. 95% what? 5%. So now we'll study some examples. That means application of t distributions. Example 1, a random sample of size has 53 as mean. The sum of squares of the derivation from the mean is 135. Okay, sum of squares of the derivation from the mean 135. Can this sample be regarded as taken from the population having 56 as mean? Obtain 95% and 99% confidence limits of the mean of the population. Okay, from our given problem, suppose H naught is the null hypothesis and there is no significant difference between the sample mean and hypothetical population mean. Okay, H naught is the null hypothesis in that case. Now H naught mu equals to 56. This is given actually. 56 equals to what? This sample regarded as taken from the population having 56 as mean. Okay, mu, population mean. Okay, mu is what? Population mean. So for population mean, null hypothesis will be what? 56. Now for population mean, alternate hypothesis will be what? 56. Okay, and not equal to 53 because null hypothesis equals to what? 56. This is why alternative hypothesis must not equal to 56 for two-tail test. Understand? Now, for, according to the T distributions formula, x bar minus mu divided by s by root of bar n variate to what? N minus 1 degrees of freedom. Okay, difference, n minus 1 difference. Now, given x bar equals to what? X bar sample mean what? 53, and population mean mu equals to what? 56 given, and n equals to sample size 16, n equals to what? 16. Now summation x minus x bar whole square, this is given sum of squares of the derivation from mean, that means x bar minus x bar whole square equals to what? 135 given. Okay, so s equals to what? Square root of our summation x minus x bar whole square. Now n minus 1 means what? N 16 minus 1, this is why 15 equals to what? 3. So t equals to, we can calculate using this. This is actually what? Minus 4. So absolute value of t equals to what? 4. So degrees of freedom what? N minus 1. N means what? 15, 16 minus 1 equals to 15. So at conclusion, 5% significant equals to 1.753. From where we got this? Actually from table. From table of what? Students T distribution. So in the table of significant value at degrees of freedom T distribution for two-tail test, we get, if degrees of freedom in our problem, degrees of freedom what? 15. Okay, so in 50% significant value is what? 0.69, and in 10% significant value is what? 1.75, and in 5% significant value what 2.13, and in 2% significant in table values what 2.60, and in 1% significant at degrees of 15 2.95. Remember it, this is the 1% significant, and this is the what actually 1 by 100%, that means 1000%. So this is a very important table for significant values of t distributions. Remember it. Okay, at 5% significant, what 1.753. This is the table values. Okay. Now the hypothesis is because our calculated value is 4. So it is greater than the critical value. The 4 is greater than the table values, right? Understand? Our calculated value is greater than what? Tabled value. So the calculated value of t is more than the table value. So the hypothesis is what? Rejected. If it is greater than our if the calculated value is greater than the table value, then the hypothesis will be rejected. We have taken null hypothesis is what? 56. So the alternative hypothesis will be accepted. Remember it in this case. Hence the sample mean has not come from population having 56 is mean. So 95% confidence limits of the population mean. What will be x bar plus minus s by root over n t 0.05. This is the formula for 90% confidence. So x bar equals to what? X bar, this is the given mean. X bar sample mean 53, and s is the what? 3 root over n means what? Number of sample, and t 0.05 what? 01 what? At 5% at 1%, 2.602. It's come from what? Table. Remember it. So for positive we get these values, and for negative this we get these values. Clear? This is for what? 95%, 5%, and this is for 1% significant level at degrees of freedom what? 15, and this is the 5% significant level. We get this, and this value comes from where? Table value, and this is also from table value for 1% significant. Remember it, because 95% confidence level limits for the population means. So rest will be what? 1%, and if 95%, then rest will be what? 5% significant. Similarly, example 2, the lifetime of electric for a random sample of 10 from the large consignment gave the following data. Item, there are 10 items actually, 10 items, and lifetime 1000 hours. This 4.2, 4.6, this is the lifetime of a bulb. Everybody is energy bulb. You can consider this as an energy bulb. Okay. Now, can we accept the hypothesis that the average lifetime a bulb is 4000 hours? Okay, we accept this, but unfortunately, this is written in a bulb, in the wall of a bulb, 4000 hours lifetime. But we can test now. Suppose age net is the null hypothesis, there is no significant difference in the sample mean and the population mean. That means mu equals to what? 4000 hours. We have taken it. Now applying t-test, t equals to x bar minus mu divided by s divided by root over n. X is the sample mean, mu is the population mean, and s is the standard deviation, and root over n is the number of sample. So here is variate to what? How many degrees of freedom? How many? 10 minus 1, because total sample 10, and 10 minus 1 will be the degrees of freedom. So here x equals to given second rows, and x minus x bar what will be? This x bar, which one? X bar 4 minus 4. Understand? 4 minus 4 is the mean. X bar what will be? Summation x divided by n. 44 divided by 10. This is why x bar equals to what? 4 minus 4. and x minus x bar will be this second rows, and x by x minus x bar whole square means this is just taking a square, we get third rows. So from the table x by, we get this 4.4, and summation x minus x bar whole square equals to what, 3.12, and we get standard deviation from that by using, for total population we get this standard deviation 0.589, and students t distribution will be what, just using this formula we get 2.123. Okay, so for gamma equals to 9, gamma means what, 9 degrees of freedom. Here degrees of freedom what, 9, and t equals to what, 0.05, 5% significant level 2.26. It's come from where, it's come from table, right? For degrees of 9, degrees of freedom 9, we get from table what, for students t distribution 9, 5% significant level what, 5% for the degrees of freedom 9, 5% significant level what, 2.26, right? Understand? Hello, understand
Yes,
everybody?
sir.
For degrees of freedom 9, we get these values. Understand? So okay, t distribution this maybe, okay, so 5% significant level 2 point what, this is example 4, we are in example 3 maybe 2 maybe, okay, right, this one. So at 5% significant level for degrees of freedom 9, 2.26, this come from where, table. Now we can comments with this, since the calculated value of t is less than table value, understand, our calculated value is less than what, table value, at what, 5% significant, the hypothesis mu equals to 400, 4000 hours is accepted. Understand? This is accepted. If less than, this will be accepted. If greater than, this will be rejected. Similarly, example 3, we can uh, solve a sample of 20 items. Actually, there are 20 items, number of sample 20, and mean, having mean 42. Sample mean 42. Mu equals to what? So, mu equals to what? Sample mean 42 units and the standard deviation 5 units. Test the hypothesis that it is a random sample from a normal population with mean 45 units. We have to test. Suppose H0 is the null hypothesis, there is no significant difference between the sample mean and the population mean. Same words we are writing. So mu equals to what? Sample population mean equals to 45. So this alternative hypothesis will be not true because two-tail test. So given total sample n equals to 20 and x bar equals to sample mean 42 given. This is the 42 and s equals to standard deviation 5 given, and gamma equals to what will be, degrees of freedom what will be, 20 minus 1. So gamma equals to what will be, 20 minus 1, 19 degrees of freedom. Okay. So standard deviation we can calculate from this, s square equal to n minus 1 into s square, capital S square. Capital S is the what? Standard deviation 5 units. So after calculation, we get this as s equals to what, 5.129. Now applying t test. This is the formula for t distribution. We get this minus 2.615, but this can never be what, negative. So absolute value of t will be positive 2.615. Actually, this at 5% significant level in 19 degrees of freedom, what will be value from table 2.09. So this is the actually greater than table value. Understand? So H naught will be what? Rejected. There, that means alternative hypothesis will be accepted. Remember it. If null hypothesis is rejected means what? Alternative hypothesis is rejected. That means alternative hypothesis what was? This is not equal to 45. That means what? We can write there is significant difference between the sample mean and population mean. That means there is a significant difference. Having significant difference. Hence, we can conclude that the sample could not have come from this population. Similarly, example 5, 4, just for this 51, does the mean of these values differ significantly from the assumed mean? Okay, null hypothesis taken 47.5. So alternative hypothesis will be what? Not equal to 47.5. And number of sample 9 given, mu is the what? Population mean 47.5. So a similar process we can proceed as our previous example. We get s equals to what? This. The applying t-test, we get 1.7279 after calculation. Okay. So at 5% significant level, we must know from what? From table 2.31 for degrees of freedom 8. Okay. But this is less than what? Table value. If less than from the table value, this will be accepted. Hypothesis will be what? Null hypothesis will be accepted for less than. So there is no significant difference between their mean. Now t-test for difference of means of two small samples. Yes, this test is used to test whether the two samples x1, x2 dot dot x n1 and y1 to y2 dot dot yn2. That means sizes n1 and n2 have been drawn from two normal population with mean mu1 and mu2. Then in this case, students t distribution will be, formula will be this. Understand? T equals to x bar minus y bar s into square root over 1 by n1 plus 1 by n2. And variate to what? Degrees of freedom what will be? N1 plus n2 minus 2. Remember it. This is the for finding difference of degrees of freedom. So if the two sample standard deviation S1, S2 are given, then S square equal to formula will be this. And if all samples are same, first sample and one, second sample size and two equal, then T distribution will be formula this. And if the pairs of values are in some way associated, we can't use the test significant test statistic as given in number previous note 2. In this case, we find the difference of associated pairs of values and apply the single mean. Single mean t equals to x bar minus mu. This is our previous formula with degrees of freedom what? N minus 1. Though, so that t test statistics t will be d bar divided by root on, and d bar is the mean pair difference. Remember it. So t d bar divided by s by root n minus 1, and difference will be xi minus yi. If you try to understand this example, I hope everybody will understand. Suppose two samples of sodium vapor bulb. This is also bulb. Sodium bulb. Sodium vapor bulb were tested for length of life and following results are obtained. Type 1 and type 2. Size 8 and size 7. Type 1, 8 size. Sample mean this 1234 hours and standard deviation 36 hours. Type 2, sample size 7 and sample mean 1036 hours and sample standard deviation, sample difference 40 hours. Okay. So is the difference of the mean significant? To generalize that, type 1 is superior to type 2 regarding the length of life. So null hypothesis equals to mu1 equals to mu2. That means type 2 bulbs have the same lifetime. Okay, same lifetime. Mu1 equals to what? Mu2. So alternate hypothesis will be what? Alternate hypothesis will be greater than mu2. That means type 1 is superior to type 2. Understand? Mu1 greater than means what? This is the superior. So s square equal to formula what? For a standard deviation for two types of sample. This is the formula. And after putting these values, S1 equals to what? 36. S2 equal to what? 40. Okay. N1 equal to what? 8. N2 equal to what? 7. Just putting these values, we get S equals to 40.7317. Now T statistics for a student's T distribution. T statistics will be T equals to x1 bar minus x2 bar S into root over 1 by n1 plus 1 by n2. X1 bar means what? This is the sample mean 1, 2, 3, 4, and second sample mean 1, 0, 3, 6, and S is the value of this calculated, and 1 by n1 means 1 by 8 plus 1 by n2 means 1 by 7. So after calculation, this is the 18.1480. Understand? And vary it to what? What the difference? Degrees of freedom what will be? N1 plus n2 minus 2. So degrees of freedom means what? 8 plus 7 minus 2. 8 plus 7 minus 2 means what? 13. Okay. So at 5% significant, for the difference or degrees of freedom 13, the table value is what? 1.75. Understand? 1.75. Since the calculated value is more and more greater than this, so null hypothesis is rejected. So alternative hypothesis is accepted. So type 1 is definitely superior to type 2. Understand? Because this is the accepted statement. Where x bar equals to what? I equals to 1 and I xy and capital Y equals to this, and S square is the standard deviation, is an unbiased estimate of the population variance sigma square. So T follows T distribution with this degrees of freedom. Actually, this was the formula for this 13. Okay, n1 plus n2 minus 2 what? 13. Similarly, you can solve example 2 using the same statement, same procedure. A sample size of 10 and 14 are taken. There are two types of sample size. Normal populations with the standard deviation given these two. Okay, S1 and S2. So the sample means are found to be 20.3 and 28.6. Sample mean is the X bar, Y bar. So test the two populations are the same at 5% level. Now we have taken null hypothesis mu1 equals to mu2. That means the mean of the two populations are the same. Okay, we have to test the population are same. Okay, population are same. Test. So we have taken null hypothesis this. So alternative hypothesis will be not same. So x bar given, x2 given, n1 given, n2 given. This is the given from given question. Now s equals to formula. Using this formula, we get s equals to 4.772 and t equals to using this formula 0.8604. So at 5% significant level, the degrees of freedom what here actually n2 means what? 24 minus 2 what? 22 is the difference. That means degrees of freedom 22. So for degrees of 22 degrees of freedom at 5% significant level, from table value we get what? 2.0739. Understand? This is less than, our calculated value is less than, more and more less than table value. So we can conclude that the hypothesis is accepted. If less than, hypothesis is accepted. If greater than, rejected. Remember it. Similarly, example 3 will be homework for you. I hope everybody can do this just using the previous table and using previous procedure. There are two sample for x1 and this is the another table for what? X2. This is for x1 and this is the x1 given values and this is the first sample and this is the second sample, and x1 minus x bar means what? X1 bar means what? Summation x1 divided by first total number of sample of first sample. So total number of frequency for the first sample size n1. Understand? Then x bar equals to x1 bar equals to 68 and summation x1 minus x1 whole square will be what? 60 using this table. For x2 same procedure, we get x2 bar equals to what? 67.66 and summation x2 bar whole square equal to, using this statement, just summing, taking sum, we get 60. Now s square will be, standard deviation will be what? 1 by n1 plus n2 minus 2 summation x1 square first sample square summation second sample square, just we get s. So under null hypothesis t equals to what? This is the formula, this was the formula, previous formula, calculating 0.3103. For degrees of freedom n1 plus n2 minus 2 equal to how many samples here actually? First sample what? First sample, how many here? 1, 2, 3, 4, 5, 6 sample. 1, 2, 3, 4, 5, 6, 7, 8, 9 sample. 6 sample and 9 sample. So 6 plus 9 minus 2, what? 13. Okay. So for 13 degrees of freedom, the table value at 10% significant 1.77. So our calculated value is more and more less than this. So the null hypothesis is accepted. So there is no significant difference between their averages. Very easy. I hope everybody can do this. Understand? Okay, example 4 will be homework for you. Now example 5. Memory capacity of 9 students was tested before and after a course of meditation for a month. State whether the course was effective or not from the data below in same units. Before this and after this. Okay, for 9 students, sample size 9. The solution, since the data are correlated and concerned with the same set of students, we use pair t-test. H naught is the null hypothesis. H naught null hypothesis. Training was not affected. Training was not affected. mu1 first population mean, and alternative hypothesis will be not equal. Okay, so before training, this was given table values x before training it, and after training y. So difference this and d square is this. Understand? Now d bar equals to what will be summation d divided by n. So we get this s square equals to, this is the formula, standard deviation formula, difference. This is the values s. So students t distribution for difference. This is n minus 1 degrees of freedom. So this is the actually minus 1.359. But the table value at 5% significant level and for 8 degrees of freedom. That means how many sample here? 9 sample. Understand? 3, 6, 9. 9 sample. This is why degrees of freedom is 8. 9 minus 1. So at 5% from table we get 2.31, but it is less than, this is the absolute value. This is the less than the table value. So S1 is accepted. If less than, null hypothesis is always accepted. So training was not effective in improving performance. Null hypothesis was training was not effective hypothesis. So we can take this statement and you can reject this statement. So similarly, example 6 for sample 1, sample 2. Analyze whether the sample have been drawn from the population of equal means. That means mu1 equals to what? Mu2. This is the null hypothesis. So alternative hypothesis will be not equal to. Understand? So first simple sample size 10. How many here? 10 sample size. And another one is also 10 sample size. So by calculating x1 is the first sample, first column, first row, and x1 minus minus x1 bar, we get this. Then summation, then square, taking a square, and for sample for second row, sample 2, and x2 minus x2 bar, we get this and square this. The x1 bar, how many? X1 divided by total sample size of first sample. This x2 is this, and summation will be total sum, taking sum. You have to use calculator, remember it, and it will be time consuming for you only. So a standard deviation for this we get as our previous example, s equals to this 7.82. So under H naught, the test statistics is given by t equals to this.
Sir, sir, Assalamu
So,
alaikum.
walaikum assalam. Okay, under H naught, null hypothesis test statistics t is given by what? 0.76 is but at 5% level, at 18 degrees of freedom. 18 from comes from where? Actually, 10 plus 10 minus 2. First sample size 10, second sample size also 10. So 10 plus 10 minus 2, what? Degrees of freedom. 10 minus 2, that means 18. So from table, the t distributions table, Okay, students distributions table for sample size for degrees of freedom 18. The critical value will be what? At 5% significant level, 2.1. Understand? So this is actually our calculated value is less than table value. Understand? So H net is accepted, null hypothesis accepted. So there is no significant difference between their mean, and two samples have been drawn from the population of equals mean. Actually, there is some homework for you. 1, 2, 3. 1, 2, 3. Note down everybody. 1, 2, 3. Homework for assignment. Assignment 1, 2, and 3. Page number what was actually for this homework? Page number 32. Okay. So in previous one, previous 1, 2 example. Okay, 1 and 2 will be homework for you. 1 and 2. 1 and 2 homework. Page number 25. Understand?